Hi there, welcome to IEL Tutors. In this video, we will learn about 3D shapes with names, nets, faces, vertices, and edges. Please have a look at some of the key terms that will be used in this video. Let's start from question number 1. It says the diagram shows some solid shapes and some mathematical names. Draw an arrow from each of the solid shape to its mathematical name. Right, so let's start. I can see on the first shape on the left-hand side is a cone, as many of you may know. So this should be matched against here. Okay, cone. Next one is a cube. So this will be matched against cube. And the next one is triangular something. Is it triangular prism or triangular pyramid? If you look at the name, it says triangular prism. So it must be triangular prism then. And the very last one is, it's just like a ball. Okay. So a very round thing. Okay. So it's a sphere. Right. The shape on the top left has a square base, and it's a bit like cone because it has a tipping point. That's why I will say it's a square-based pyramid. The next shape has a cross-section of pentagon. So it's a pentagonal, not pyramid, but prism, because it's a bit like cylinder. If you see, it has a cross-section, pentagonal face at either end of the shape. So that's why it is a pentagonal prism, not pentagonal pyramid. We'll move to the next one. That is a cylinder. I hope many of you will know this already. Okay, so it's a cylinder. And if we move to the next one, that has a pentagonal base, but it looks like a bit like a cone. So that's why I would say that it is a pentagonal pyramid. Next shape, I hope many of you would know already, is called a cuboid. It's very similar to cube, but it's all of its lengths, all of its dimensions, they're not exactly the same. So that's why it's a cuboid. And that's, by the way, that was the only option left. Let's move to question number 2. It says, here is a diagram of a cuboid. Write down the number of faces, edges, and vertices. Right, so if I look how many sides the shape has, I can see 4 sides all around, front, right, left, and back, and also top and bottom. So that's why I would say it has 6 faces. Okay, how many edges does it have? Edges are the line. If I just want to see how many lines are there, so I can see 1 there, 1, and then 2, then 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So it has 12. That's why I would say it has 12 edges. Edges are the lines that connect its vertices. And then moving to the next one, then it says vertices. How many vertices does it have? Vertices are corners. Okay, so 1, 2, 3, 4, 5, 6, 7, 8 corners. So the shape has 6 faces, 12 edges, and 8 vertices. Moving to part B, it says, here is a diagram of a triangular prism. Write down the number of faces, edges, and vertices. How many faces does this shape have? I can see a triangular face in the front and also a triangular face in the back. And I can also see a rectangle, which is slope rectangle there. And I can also see a rectangle in the base. I can also see a rectangle in the back. Okay, right, so altogether I can see 2 triangles and 3 rectangles. So altogether there are 5 faces. How many edges does it have? If I count all of the lines which are there, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 edges. How many corners does it have? 1, 2, 3, 4, 5, and 6. So altogether it has 6 corners, so that's why 6 vertices. Moving to part C of the question, it says, here is a diagram of a square-based pyramid. Write down the number of faces, edges, vertices. How many faces the shape has? I can see there's a square base in the bottom, and I can also see 4 triangles. So 4 plus 1 will be 5. So it has 5 faces. How many edges does it have? Let's trace its edges. 1, 2, 3, 4, 5, 6, 7, 8. So altogether it has 8 edges. And how many vertices does it have? Let's see how many corners the shape has. 1, 2, 3, 4, 5. Right, so it means that it has 5 vertices. Moving to part D of the question, it says, here is a diagram of a cube. Write down the number of faces, edges, and vertices. How many faces does it have? Just like a cuboid, it has 6 faces, 4 sides, top and bottom. So 6 faces. How many edges does it have? I can see 4 edges on the top, 4 in the bottom, and 4 lines connecting them. So 4 plus 4 plus 4. So 12 edges. How many vertices does it have? I can see 1, 2, 3, 4, 5, 6, 7, 8 edges. Moving to part E of the question, it says, here is a diagram of a triangular base pyramid. Write down the number of faces, edges, and vertices. Right, how many faces does it have? I can see it has a face in the base. So it's a triangle, that's why it's like, which is a triangle, that's why it's called triangular base pyramid. And then it has 3 other triangles as well. So that's why altogether 4 faces. How many lines can I see in this, which are connecting vertices? 1, 2, 3, 4, 5, 6. So that's why it has 6 edges. And how many vertices does it have? 2, 3, 4. So altogether 4. So altogether it has 4 faces, 6 edges, and 4 vertices. Moving to part F of the question, it says, here is a diagram of a pentagonal pyramid. Write down the number of faces, edges, and vertices. Right, I can see its base is a pentagon, so that's 1 face. And then I can see 1, 2, 3, 4, 5. 5 triangles. So 5 and 1 will be 6. So altogether it has 6 faces. And I can see that in the base there are 5 lines that make a pentagon, and also there are 5 lines which connect these to the apex, to the tipping point on the top. So that's why 5 at 5 would be 10. So how many vertices does it have? Let's count them. 1, 2, 3, 4, 5, and 6. So it means in total the shape has 6 faces, 10 edges, and 6 vertices. Let's move to part G of the question. It says, here is a diagram of a hexagonal prism. Write down the number of faces, edges, and vertices. Right, so I can see a bottom face, which is a hexagon, and the top face, which is also a hexagon, and I can see 6 rectangles which are connecting those faces. So 6 add 2 will be 8. It has altogether 8 faces. And how many edges are there? There are 6 edges in the base, 6 on the top, and 6 connecting them. So 6 times 3 will be 18. So it has 18 edges. How many vertices does it have? 1, 2, 3, 4, 5, 6 edges, 6 vertices in the bottom, and 1, 2, 3, 4, 5, 6 in the top. So 12 vertices altogether. Moving to part H of the question, it says, here is a diagram of an octagonal base pyramid. Write down the number of faces, edges, and vertices. As we can see that there is a face which is an octagon in the base of the shape, and then 8 triangles, so 8 plus 1 will be 9. So it has 9 faces. How many edges does it have? 8 in the bottom and 8 connecting them to this point here. So 8 add 8 will be 16. And how many vertices does it have? I can see 1, 2, 3, 4, 5, 6, 7, 8, and 9th one, so 9. So altogether, an octagonal base pyramid will have 9 faces, 16 edges, and 9 vertices. Let's move to question number 3. It says, write down the mathematical names of the following shapes. Right, the first shape I can see is a triangular prism. Right, the next shape I can see is a cube. And one after, third one is a cone. Fourth one I can see it's very similar to cube, but it's longer. So it is a cuboid. Moving to the next shape, I can see its base is a square, so it's a square-based pyramid. And if you look at the next one, I can see it's a prism. What type of prism it is? It is a pentagonal prism. And the next one is a cylinder. And the one after is, I can see its base is triangle, and it's a bit like a pyramid, so it must be a pyramid. But what type of pyramid? Triangular-based pyramid. Triangular-based pyramid. Moving to the next shape, I can see it's a prism because it looks a bit like cylinder. It has a cross section at top and bottom. What is the cross section of this shape? I can see it is a hexagon. So it's hexagonal prism then. Hexagonal prism. And the next one is a bit like cone. Let's see how many edges are in its base. 1, 2, 3, 4, 5, 6, 7, 8. So that's why it is an octagonal pyramid. Let's move to question number 4. It says select true or false. Right. Statement number 1. It says all prisms like a cylinder have a cross section. Yes, I would say true. All pyramids like a cone have a tipping point. I would say true. Pyramids can be cut into identical pieces. I'm afraid not, so that's why it is going to be false. Moving to statement number 4, it says prisms can be cut into many identical pieces. Yes, and all of those faces, they will have cross sections. So true. Cubes and cuboids are prisms. Yes, because we can see a cross section. Right, moving to number 6, it says cross section is a face that goes from one side of a prism to another. Yes, that's true. Moving to number 7, it says triangular-based pyramids have 4 faces and 4 vertices. Yes, that's true. Number 8, pentagonal-based pyramids have 6 faces and 6 vertices. That's also true. A hexagonal-based pyramid has 6 faces. I'm afraid not. It has 7. Why? Because there is one face which is in the base that is a hexagon, and there are 6 more triangular faces. That's why altogether there will be 7 faces, not 6. Moving to number 10, it says a square-based pyramid has 4 faces. That's false. It will have 5. Moving to number 11, it says prisms can be compared to cylinders as both of these shapes have a face cross-section that goes from one side to the other. Yes, that's true. Moving to number 12, it says pyramids can be compared to cones as both of these shapes have an apex or a tipping point. That's also true. 2 identical cubes are joined back to back. The new shape will have a higher number of vertices than a cube. No, it will have exactly the same. A pentagonal pyramid will have 15 edges. Again, I would say false. A pentagonal prism will have 15 edges, but a pentagonal pyramid will have 5 in the base and 5 connecting to the apex or the tipping point, so 10 only. Let's move to question number 5. It says, draw an arrow from each of solid shapes to tell if the shape is a prism or pyramid. Right. If we just see the first one is a prism because we say it's a triangular prism. Second one, if we see, is also prism. It's a U-shaped prism because I can see this U face at either end of the shape. So this is also prism. Okay. Moving to the next one, this looks like a bit like a cone. So that's why I will say it's a pyramid. Moving to the next one, cubes and cuboids are always, we must remember that cubes and cuboids are always classed as prism. Square-based pyramid, as I've mentioned its name, it's a pyramid. It's a bit like a cone. So it's a pyramid. Right, looking at these shapes, the top one is a pentagonal prism because it's a bit like a cylinder. Pentagonal face, pentagon can be seen at either end of this shape, so that's why it is prism. Okay, moving to the next one. What shape is this? It's upside down at the moment, but standing vertical, but it is a triangular prism because I can see triangle at either end of this shape, so it's a prism. Triangular prism. Moving to the next one, that's an L-shaped prism, so it's a prism as well. And moving to the next one, it's a hexagonal prism, so it's also a prism then. The last one is a triangular-based pyramid. I hope you found this video useful. Please don't forget to like, subscribe, and share with your family and friends. I should see you in my next video very soon. You take care of yourself. Bye-bye.